Hi, hello, I am Kiran Kumar from Nature of Physics. Today, horizontal projection from top of the tower, part 2 video student. Part 1 video, path of the projectile is parabola, completed. And time of descent, horizontal range and magnitude of final velocity and direction of final velocity we will discuss in this video student. So part 1 video I will give in the bio. See, time of descent, first I am finding before the diagram explanation. H is the height of the tower student, and R is the horizontal range. Initial velocity u, and initially theta is equal 0. This is parallel to the ground student, and initial velocity resolve into two component. Horizontal initial velocity u cos 0, so that I got ux is equal to u cos 0 is equal to 1, and uy is equal to u sin 0 student. So I got uy is equal 0 because of sin 0 is equal 0, 0 into anything 0. And time of descent I am going to find the best equation for time of descent. S is equal to ut plus of at square student. In this equation, displacement S is equal to vertical displacement student, S is equal to y, and u is equal to uy, that is equal 0 student, and downward direction A is equal plus g, and t we are writing as td student. Okay, and continuation equation, the values replacing in the above equation, that is y which is equal to 0 into anything 0 half into gt square student. Okay, so that here y is equal to h student. How much? Y is equal to vertical displacement is h here. Okay, so that h which is equal to half gt square. Okay, we can directly write s is equal to h. So 2h by g is equal t square student. So finally I got t is equal root over 2h by g, but time is taken as time of descent td student. Td is equal to root over 2h by g. Here time of ascent is equal to 0 and time of descent only we have. That's why time of flight which is equal time of ascent and time of descent, because of here the body is projected from the top of the tower, so there is no time of ascent student. So time of flight capital T which is equal to 0 plus td student. So finally I can write time of flight t is equal root over 2h by g student. See there. Okay, this is equal to 0 plus root over 2h by g. Time of ascent is equal 0, only time of descent is there. That's why time of descent is equal time of flight here. And horizontal range capital R student, this is the horizontal range. Okay, for horizontal range also using same formula, S is equal to ut plus of at square student. Horizontal direction considering, that's why here sx, ux and ax student, and values are replacing there. Sx is equal to horizontal range r, and ux is equal to u, and ax is equal to 0 because of ux is equal to constant and differentiation of constant is equal 0. Okay, so that time t, it is written as the time of flight student, capital T. Okay, now replacing the values in the above equation, tell me student, r which is equal to ux is u into t plus of ax is equal 0 into t square. So that r is equal to u into t student. Okay, so t value is equal to, I wrote time of flight student, so r is equal to u into time of flight, so we got root over 2h by g. This is written as equation number 1 student, and this is equation number 2, and this is equation number 3 student. See there, time of descent and time of flight taken equation 1 2, and horizontal range is taken as equation number 3, students. And continuation derivation, next I am going to find ux and uy that represent the final velocity, student. For this final velocity basic equation, v is equal to u plus at, so vx is equal to ux plus axt, student. Okay, vx is equal to ux is equal to u, okay, given clearly, and ax is equal to 0, student. 0 into anything 0, clearly proof also given. Finally we got vx is equal to u, student. This is written as equation number 4, and vy which is equal to uy is equal 0 plus ay is g, student, and t, so that finally I got vy vertical final velocity is equal to gt is written as equation number 5. Okay, and magnitude of final velocity finding, before that v bar which is equal to vx is equal to u I got, and vy is equal to gt I got, student. This is taken as equation number 6. Magnitude and direction I am going to find, student. Here for magnitude, this is 2-dimension vector, diagonal square is equal side square plus side square, student. That is diagonal represent final velocity, that is v square which is equal to vx square plus vy square, student. So that v which is equal to root over vx square plus vy square. So v which is equal to root over vx is equal to u, that is u square, this is gt whole square, student. Now I can write this is equation number 7. Okay, we can replace the values also. Replace it clearly, student. And continuation, last step here, direction I am going to find. They are clearly given, student. This is vx and this is the vy, student, and this is taken as v. It is making an angle alpha, student. For this tan alpha which is equal to vy divided by vx, vertical divided by horizontal, student. So the tan alpha which is equal to, we can write vy is equal to gt divided by vx is equal to u. This I can write equation number 8, student. And also next step we can write like this, student. So alpha which is equal to tan inverse of vy by vx, and next alpha which is equal to tan inverse of vy is gt and vx is equal to u. Horizontal component of velocity remains constant. Thank you, student. Please like and subscribe my channel.